Hello, today we're going to talk about lights and pigments, and without further ado, let's just jump right into it. Light energy is a form of electromagnetic radiation which travels in waves and is measured in wavelengths. This is an example of an electromagnetic spectrum. As we can see right here, the visible spectrum or the visible light is the only part of the electromagnetic spectrum that we humans can see with our eyes. And these lights also helps us to see. There are also other kinds of electromagnetic radiation that we encounter in our daily lives, including radio waves, microwaves, and sometimes X-rays.
Let's have this bass as an example. When I pluck the strings, it sounds low because of the thicker strings and the longer wavelength it has to travel. But when I put my finger up here in higher fret, it produces higher sound because it has shorter wavelength, higher energy.
The longer the wavelengths, the lower the energy. The shorter wavelengths, the higher the energy. Visible light. Most of living organisms in Earth depends on the light from the sun. I'm talking about the plants, algae, and other organisms who depends on light to create their food. Visible light from the sun appears as white, but it's actually made up of multiple wavelengths, colors of light.
A white light contains all the different colors, but you can only see these colors when the light passes through certain items like a prism, raindrops, or even a pen.
It is because the different wavelengths of light are bent or dispersed at different angles as they pass through the prism. They spread out and form what we see as a rainbow, with the violet and blue having shorter wavelengths and therefore they have much higher energy. But at the end of the spectrum towards the red part, the wavelengths are longer, thus having lower energy. And visible light is not only a wavelength, it is also composed with small particles called photons. Light and other EM radiation is also composed with this particle, which has certain amount of energy. When an atom absorbs a photon of light, it becomes more excited, meaning that it has extra energy and is no longer in its normal or ground state, causing the electrons to jump from a lower energy orbital to a higher energy orbital. Whenever there is a change in a system, energy is transferred and some of that energy is dissipated. Any energy that is not transferred to useful energy stores is said to be wasted because it is lost to the surroundings as heat. Fluorescence is the emission of light by a substance that has absorbed light, and in most cases, the emitted light has a longer wavelength and therefore a lower photon energy.
When I was a young boy, my mother was doing all the laundry, and then she called my name. She said, "Son, when you go out, would you be buying me detergent? 'Cause I need to use some." One day, my mom was doing the laundry and we ran out of powder detergent to use. So she asked me to buy some from the nearest sari-sari store. And she asked me for a specific kind. She asked me to buy a violet surf powder.
Ano po yun?
Surf violet po, isa lang. Salamat po. Do you wonder why this appears to us as violet? We see this as violet because it absorbs all the white light except the violet color, which is reflected.
Pigments are molecules which absorb specific wavelengths or light and reflects the wavelengths or light they cannot absorb. But sometimes, there is no color that is reflected. That is why some things appear as different colors when under different color of light. The original color of the pen is green and white when struck by a white light. But let's see when we remove the blue and green light. As we can see right here, the pen became red and black because there is no color that is reflected. The colors or light is only absorbed. Now let's talk about the pigments in plants. This is what chloroplast looks like. Different parts of the chloroplast includes outer membrane, which acts as a semi-permeable membrane allowing only the passage of small organic molecules that is necessary for the photosynthesis. There is also this inner membrane, which is studded with various proteins, encloses an inner fluid-filled region called the stroma. These little tiny parts inside are what we call the thylakoids, and the grana or granum are the stalks of these thylakoids. Chloroplast is an organelle in the mesophyll 2 of the leaves. It is the one who helps the plants to convert water, energy, and sunlight and into food or sugar or what we call the glucose. All photosynthetic organisms contains a pigment that is called chlorophyll A, which humans see as the common green color associated with plants. Chlorophyll molecules includes a hydrophobic tail that inserts into the thylakoid membrane, and a porphyrin ring head which absorbs light. Chlorophyll A absorbs wavelengths from both the end of visible spectrum, blue and red, but not green. Chlorophyll B helps in photosynthesis by absorbing more light energy, and it is more soluble than chlorophyll A. There is also different types of pigments that we can find in plants called the accessory pigments. One example is the carotenoids, which reflects yellow, orange, and red light. Carotenoids in chloroplast helps absorb the excess energy and dissipate it as heat. And the accessory pigments are used to maximize the amount that the plants can absorb. Chlorophyll A and chlorophyll B are very efficient in absorbing light, especially in 400 nm to 600 nm.